30 minutes, Tatjana Pejcinovic, data lead, and Petra Sinka, data scientist from the True North company, will introduce the Guardian, fraud detection using graph analysis. This solution leverages graph databases, advanced analytics, and machine learning to detect and prevent fraud. Their talk will showcase how Guardian's network model enables efficient detection and visual exploration of suspicious behavior, empowering users to better analyze and investigate fraud cases. So the stage is all yours, ladies.
Thank you. So, hello everyone. First of all, thank you for being here. I know it's quite late in the day and you must be tired, but we'll try to make it interesting and also not too long. So today we will present a little bit about Guardian, which is a solution that we developed internally in our company to leverage graph analysis to detect all different kinds of fraud. First, a little bit about us. So, yeah, as you already heard, my name is Tatjana, and I work as a data lead in True North. I actually, before joining True North, also worked in Allianz Group for 10 years, where one of the models that we were also developing was detecting fraud in insurance claims. So it's not necessarily, cybersecurity, but still fraudulent and suspicious behavior.
Hi everybody, I'm Petra and I'm data scientist and analyst in True North. I'm also a mathematician, passionate about statistics and analyzing data and patterns. For the past 2 years in True North, I have worked on several projects about fraud detection, the last one being Guardian, and I have helped clients gain and use insights from data in optimizing their business processes.
Okay, and just briefly about True North, just so that you get the story, how did we come up with the idea for this product? So basically, we are a relatively young company that exists a little bit more than 3 years, and in the meantime, we grew to a bit more than 60 people. And we do we focus on 3 different areas. One is that we build and design software solutions, and then also platforms that run these software solutions, and then data and analytics solutions. And we work mainly with large enterprises, so basically with banks, with companies from public sector, and the data that they have can focus around different parts of the economy and the fraud that they are interested in, like, for example, tax fraud or suspicious behavior in, I don't know, importing goods into the country, etc. And it's not so, there is a lot of data, but it's not so straightforward to see all of the relationships between the data. So it's a little bit different than, I don't know, the typical kind of credit card fraud and just processing transactions and seeing anomalies. It includes a lot broader universe of the data. And when we started to talk with our clients around, okay, where do you get stuck, and what could we do? That's how we come up with the idea of maybe developing a solution that could package all of this in one place. So briefly, the agenda for today. So Petra will explain a little bit around the cost of fraud and why is it such an issue, especially to kind of investigate and validate fraud. Also, what is Guardian? How did we prepare the data for this? How did we build the graph? We use also some machine learning models there. And how do we actually leverage the user input and case management? Because in fraud, especially in this type of fraud, there is not too much labeled data. Or even sometimes these fraud cases are not documented in a structured way. Sometimes it's, you need to look at some papers or some notes that someone wrote and said, okay, this was actually a tax fraud and included all of these entities. And then a little bit about the ideas that we have around how to further build on this and maybe also apply it in different domains.
Okay, to start with, let's see what are the statistics around fraud worldwide. In 2017, McKinsey & Company conducted a research about card fraud, according to which the cost of fraud was growing over the years, specifically 12% per annum. Worldwide losses climbed to almost $23 billion in 2016, and back then it was estimated that they could come close to $44 billion by 2025. Also, the average number of fraudulent transactions per US merchant rose by 34% between 2013 and 2016. Of course, all of these statistics are about the known fraud cases, so the real cost of fraud is even higher. This growth in numbers is partly a result of the rise of e-commerce and mobile payments, but today's digital transformation has undoubtedly created new opportunities for fraudsters to exploit vulnerabilities in systems and technologies. And as they continue to develop more innovative ways of fraud, it is up to organizations and individuals to remain cautious and proactive in identifying and tackling fraudulent behavior. However, detecting fraud can take a very long time. A research by Deloitte states that it takes 12 months to only detect fraud, and that organizations lose on average 5% of their revenue due to fraud each year. We then started thinking, what could help companies make the process of investigating a potential fraud more efficient? One of the key takeaways we had was that having the right insights from the data, as well as more transparency and more accessible data in general, can help and facilitate the whole fraud detecting process.
So how does Guardian come into play? Basically, when we talk to our customers, traditionally they use all kinds of rule-based engines to detect fraud. And with time, these systems kind of grew in complexity. And even some of our customers actually hired entire teams of data analysts, data scientists that help them calibrate or run different models that would help them to define the rules, which will then be built into the rule engine. And then on top of that, there is an entire team that is actually working on checking the flagged cases. Was something really fraud or wasn't it fraud? And these people usually might not be so skilled in data wrangling and checking all of the data, and they need some support. So graphs seem like a perfect way to visualize all of the data in one place. We also wanted to help them to somehow, in the same place, also record the result of their validation and maybe even define some further, okay, I was checking for this and I was checking for that, and store it somehow so that we can use it to retrain the models. Fraud cases, especially when it comes to, I don't know, tax fraud or fraud when it comes to importing goods into the country, etc., often involve a complex network of entities. So actually representing it in a graph made perfect sense. The only thing was, okay, how do we put it all together? How do we put all of the data together, and how do we build the relationships? Then we said, okay, if we present it in the graph, we can actually make it easier for the models and the users to detect suspicious behaviors, to see, here in the network it's unusually dense behavior, or in this part of the network maybe there are some anomalies when it comes to the relationships between companies, and especially if these companies, typically these kind of companies have a different behavior, or have different transactions among them, etc. Additionally, using graphs and graph databases makes it more scalable, so we can process more data faster. And then on top of that, actually what we could do, what we thought, okay, might be a good idea, that we just pull out some insights from the graph and use it as features in machine learning models, so like some centrality measures, etc. So how did we build the data into the graph? As I said, when we talk about public sector, tax administration, or banks, ideally, we thought ideally it would be great to have the entire economy represented like this, that we have companies as the nodes of the graph, and then to represent somehow the relationships, maybe the interactions between the companies, but also ownership structures. So in the graph, we have two types of nodes. It's the companies and the owners of the companies, and the relationships are then ownerships, and then we also have the transactions between the companies. Transactions can be, in the case of the banks, maybe they don't see all of the transactions, but for example, tax authorities do see all of the transactions between companies, and they are the edges of the graph. Then we wanted to somehow assign some weight to these edges so that we can know what is the strength of the relationship. But if you represent each transaction separately, it becomes quite dense. So then with some analysis, we kind of came up with the idea that we use an aggregated amount of the monthly transactions and the monthly number of invoices as the weight on the edge of the graph. But also to have a separate graph where you can deep dive into the transactions between a subset of the companies. If we talk about these monthly transactions, we also needed to somehow incorporate time, because it's important to look at this throughout time and to kind of take into account also seasonality, especially in some industries which are sensitive to this, like tourism, etc.
So once we have built the network, we thought about what kind of information could we get from its data. So we started with the exploratory data analysis and with calculation of all the important features of the graph, which can serve as additional features for our fraud detection models. We calculated for each company some basic graph metrics, such as in degree and out degree, and also some descriptive statistics of companies' financial data. We also had two groupings on which we did anomaly detection. The first grouping was based on the industry of company's business, and the second grouping consisted of pairs of industries, and we focused on the transactions between them to see if some of them stand out and potentially indicate fraud. But that wasn't all. We also used clustering algorithms for another segmentation and another possibly useful information for our models. We calculated some KPIs, such as the profit margin and the ratio of revenue to the number of employees. And we calculated some centrality measures, specifically closeness between us and PageRank. We, of course, have a lot of ideas in the backlog that we would like to develop into additional features, such as enhancing the data even further by connecting external data sources and media. For example, we could add the court register data, then external databases regarding credit ratings, potentially web scraping for detecting the sentiment of news articles related to our observed company, and maybe detecting of employees' satisfaction from forums and comments, etc. So we have gathered all of this information, and now we were ready to tackle the main challenge, which is identifying suspicious behaviors. But what is a suspicious behavior? Well, it depends on the domain. For example, one of the most common type of tax fraud is called the missing trader fraud. It is a type of VAT fraud in which a business in a supply chain charges VAT on sales, but then disappears without remitting the tax to the authorities, leaving them at a loss. The same goods are then usually resold through multiple companies, making it harder to trace the fraud back to its origin. Similar and repeating patterns appear in other industries as well. For example, money laundering and money laundering and account takeover fraud in banking, and insurance claim fraud in insurance, and so on. I would also just like to point out that Guardian doesn't have to be limited to only detecting fraud. It could also be configured to detect other unusual behaviors as well, depending on the domain. For example, it could assess the risk that a certain company won't meet its obligations, and so on. Okay, so we wanted to make sure that our tool can support all of these patterns by building a pattern library, which can be predefined and pre-configured based on the domain and the business, the use cases we would like to tackle. It can also be fine-tuned, like weights of the edges, types of nodes, etc. The tool also provides the possibility for the admin user to configure all the parameters and to define new ones. We are currently working on implementation of a new feature that would enable visual definition of new patterns by selecting a pattern on graph and asking the tool to find similar behaviors. Okay, so already all of these features can help clients significantly reduce the time needed to investigate and detect fraud. And the next step for us is to explore all the possibilities machine learning has in leveraging all of this data and making us even smarter. So far, we calculated a lot of additional features and we explored the data, but of course, not all of the data will be useful in detecting fraud. Also, we can't use all the variables and features in our model because of the correlation some of them have. That's why we used XGBoost to filter out all the unnecessary and unhelpful variables. Also, we do not have any labeled data when it comes to fraud. In the real world, there are not many known fraud cases. So we labeled as fraud all the behaviors that were suspicious based on our predefined patterns. We will now try and test different models like the logistic regression, SVM, and random forest to see if they can find similar suspicious behaviors.
Okay, and then a little bit around the orchestration of the whole thing, because it's actually the calculation is happening as a part of the application. So one of the most important parts here is actually connecting all of the data sources or gathering all of this data. As I said, sometimes it's connecting external data sources, like Petra said, maybe something from the media, maybe connecting to the court register, getting the ownership structure, maybe exploring your own data from the databases, etc. So we then defined a model that actually first lives in a Postgre database, where we store all of the data, and then we use a Python script to load this data into an Arango database, so a graph database, where we build all of the relationships between the companies. And then the calculation starts. Basically, we use Python, and in Python we use the NetworkX as the library to represent graphs. And then we have a pipeline in Airflow that orchestrates this, and we actually found NetworkX quite performant in this. And we are even thinking about skipping the part with Arango. Let's see, because the amount of data that we have is not so big, so basically we can just directly use Python. And then, as this is all a part of the application, for us it was a question, okay, what do we use to nicely represent this graph, the user interface? So we use Cytoscape, which is a library that was developed to represent graphs, mainly or networks in biology, but then later started to be used elsewhere as well. And yeah, talking about front end actually brings me to the point around how do we incorporate user input, because for us this is quite important. As Petra said, especially in tax fraud, there are not too many flagged cases, and actually people that validate whether suspicious case is fraud or not, they deal with a lot of false positives. And for us it was important to somehow make this tool very nice for them to use, so that they are able to record all of their expert judgment, all of the qualitative kind of criteria that they have, and put it back into the tool so that we can retrain the models again and again. So we then added a few functionalities that would help them, such as advanced filtering, or enable them to actually configure some rules again that would be additionally used, or patterns, and to, in the end, after they continue their investigation, to label data whether it was really fraud or not. So in the end, it looks something like this. I don't know if you are able to see it, but basically there are a few functionalities where you can find, I don't know, the shortest path between two companies on a graph, where you can filter the nodes and the edges and the weights of the edges and different features of the nodes. And the idea is that they use this to actually explore the data, but then also once they find something, they can actually store this and say, okay, this was fraud. And maybe some similar cases like this would be also fraud. There are also, again, it comes down to rule management, which I said at the beginning that might not be the best way, but we actually really needed a way to somehow capture this thinking of the people that validate the fraud. Once they actually log into the application, they have a home screen where they can see all of the cases which are flagged as fraud, and they are somehow prioritized based on the criteria that flag them as fraud. So the more criteria, the higher you're up, but there are also some weights assigned to the criteria because of course, if one of the criteria is just something is an outlier, it might just be a very big company that is doing something. So, but if the company appears in several criteria as the fraudulent case or suspicious case, then it will be higher up. And the user can then click on the company and go directly into the graph and start exploring and playing around. Okay, here was a transaction to this company, and then it was a transaction outside of the country, and then back into the country, and basically they can then find the pattern and confirm was it fraud or not. Also, it was very important to also somehow show or enable them to deep dive into the details about the company. So they can click on the node and then see some details like, I don't know, when was the company founded, how old the company is, what is the industry, how many employees do they have, how many owners, what is the age of the owners, etc. And then if they click further, they can actually see even all of the centrality measures that we calculated, all of the financial reports of this company, etc. And for us, it was really important to somehow balance out this zoom-in view on the actual details of the data and on the graph where you can zoom out and see basically the behavior and relationships with other entities. And yeah, next steps and wrap up. Basically, we really want to further enhance the data because we feel like this is a key part in kind of gathering insights. A lot of this data about the company sits somewhere in some registers, in some documents, etc. So maybe scanning some documents, structuring the data, putting it into the application. Also web scraping. I think Petra already said do some sentiment analysis of the news. Maybe see if a company appeared already earlier in some news around fraud or maybe some suspicious behavior. Maybe even network-based diffusion analysis so that we see how does the suspicious behavior or fraud kind of spreads throughout the network. And this actually can also be applied and used in other domains as well. So not just fraud, but if we talk about, let's say, the bankruptcy of the company, actually these kind of models can help us see how this will affect all related companies as well. So the idea is to start developing different modules of the application depending on the use case, whether it's fraud or kind of credit risk. And that's it. Thank you.
Okay, I guess we have a few minutes for Q&A session. Is there anyone want to ask something? Okay, just the microphone is behind you. Okay.
Thank you for the presentation. I was wondering where do you get the data set from, since I guess transactions between companies are private knowledge, and yes, how do you deal with the private nature of that data?
Well, basically, yeah, it's kind of, some of it is confidential, some of it can be found, but also it's something that we did in a cooperation with the customer. So they helped us anonymize the data and then use it. No worries.
Anyone else? No? Thank you, Tatjana. Here's your certificate. Thank you, Petra. This was such an informative presentation. And that brings us to the end of today's sessions at Data Science Europe 2024. But don't forget, the ultra early bird tickets for Data Science Conference 2025 are already on sale.